Welcome to solverfy.
Okay, we have a number of radicals, and we need to determine what the correct order of their stability is. Let me sketch those out here. Okay, now let's talk generally, right? So, well, maybe I can tell you the answer first. It's 1, but now I'll tell you why it's 1. Okay. So the reasoning for that is that radicals are stabilized when they neighbor. That is, they're on the carbon next to a carbon participating in a double bond. And the reason for that, if you recall, is resonance, right? There's a resonance form that could be drawn for this, in which the radical gets shifted over there, right? And this resonance increases the stability of the radical. So anytime you have a radical next to a double bond, its stability is increased, right? So off the bat, this one's looking pretty good. That's got resonance. This one has resonance too. What about these ones, right? What if the radical is on a carbon with a double bond, but not neighboring a carbon with a double bond? Okay, that's actually destabilizing, right? So double bonds, not talking about radicals for a second, but if you talk about electron, like how much they want electrons, sp2 carbons, right, are less needy for electrons than sp3 electrons. Okay, so in a sense, if your electron is on an sp2 carbon, you're actually having a net destabilization. Okay, so this is destabilized. This is destabilized. Okay. And these two, where it's neighboring, are stabilized. Okay, so now we know that 1 and 2 are going to be, that is, this one's going to be either 1 or 2. This one's going to be either 1 or 2. This one's going to be either 3 or 4. And this one's going to be either 3 or 4 in terms of ranking stability. Okay. Okay, so now let's talk about how we sort out the one where it's neighboring a double bond. We'll call this A, B, C, and D. Let's sort out which is more stable, A or C. Well, notice that in terms of C, the parts that matter is that it neighbors a double bond, but that double bond itself neighbors another double bond. And what is possible is that you can have resonance like this, like we did before, where it moves over by 1. Okay. The radicals here now, double bonds here. And then it can have resonance with this double bond. Like so. Okay. And the more resonance structures you can draw, the more stable something is, right? So it turns out that the C here has got to be the most stable, and A is the second most stable. And that's because C has more possible resonance forms that you can draw. From there, we need to sort out B and D. Okay, which of those is the least stable? Which of them? Which one's number 3, the most stable between the two of them? Which one's number 4? And the best way to think about this is that you can think of radical as being like an atom having lost an electron. Okay, it's got less electrons than it normally would. It's got 1 less electron than it normally would. Okay, so radicals are effectively electron deficient. Okay, now let's talk about what we were talking about before, sp2 carbons, right? sp2 carbons versus sp3, when you're comparing them, are also electron deficient relative to sp3 carbons. So the way we can compare B and D is to say, well, in B, we have 2 sp2 electron deficient atoms, whereas in D, we have 2, 3, 4, 5, 6 electron deficient atoms. So which one is more electron deficient? D is more electron deficient. I'll say D more electron deficient. Well, between B and D, which one do you think would be easier to make a radical? Remember, when you make a radical, you're plucking away an electron. You're making it electron deficient or more electron deficient than it was before. Is that going to be easier to do to something that's already very electron deficient? No. The more electron deficient the molecule as a whole is, which D is more than B, it's more electron deficient, the harder it is going to be to rip away an electron from them. So D is going to be less stable than B. And if we look at our options, that leaves, basically, we said that C has to be 1, A has to be 2. We just determined that B is not as unstable as D. Okay, and option 1 is the only one that fits that criteria, where the least stable is D. We go D less than B less than A less than C.